Today's topic is going to be on weather. This will be our last video for the day. I've already made two that was dealing with the atmosphere, and today is going to be weather, energy and weather, energy transfer and weather. And you can see like the big topics here is observation and collection of weather data, prediction of weather patterns, severe occurrences, tornadoes, hurricanes, major storms. And again, in this video, I only have 10 minutes, so I'm going to hit the most prominent topics, the big topics. So not in depth, just glancing over the big stuff. All right, energy transfer between the Earth's surface and the atmosphere creates the weather. When the energy from the sun comes and hits the Earth, once that energy hits, that's called conduction. Whenever you're dealing with solids, that's conduction. And you remember that video where the guy was talking about it's not so much what comes from up in the skies, but it comes from from below that really creates the weather. You have all kinds of natural phenomena going on from that. You have local winds like sea breezes. You have turbulence going on. You have thermals, they call them. Maybe I can show you a picture of a thermal. Thermal heat. That's going to pull up a thermal. Yes, yeah, thermal wind. That's not showing anything either. Or thermals. Let me just put thermals. Try that. And, oh, that didn't work either. That's okay. Oh, but it did right there. Let's get away from the thermals. The actual what people wear, like long johns, is what I call them growing up. But anyway, thermals. Great pictures, great illustrations here. What's going on in these illustrations is the ground is heated, and that heat is causing a convection current to go up. See, this is conduction. When the energy from the sun comes down, this is heated through conduction, but the air right here is going up through convection currents. You see the heat as it goes up, it cools down, it becomes more dense, and then falls back down, and it's reheated again by the heat coming off the ground. So radiation, conduction, and then you have convection going on, and of course that's condensation making the winds, not the winds, but the clouds. So weather and climate are different. Yeah, I mean, weather is what's happening today. It's what's happening like right now. Like today's weather is 70 degrees and sunny. Tomorrow might be 45 degrees and raining. Climate is weather patterns over thousands, hundreds, thousands, maybe millions of years, depending on where you're talking, what you're talking about, like the desert, like the Sahara Desert. The climate there has been going on for thousands and thousands of years. I mean, I don't know. It could be maybe in millions. I don't know. But yeah, that's the same climate over a very, very long time. Now, if I want to do something like the climate that's happened in Central Virginia over the last, 100 years, you could do that. Weather is what's happening today, though. All right. Weather describes day-to-day changes, like I said there. There are four major factors that impact climate, and we covered this pretty well in class. And they say it right here. Latitude, longitude has nothing to do with weather or climate. Longitude does nothing. That's the lines up and down. But flat, that has a tremendous impact on weather, and I can show that right here. All right, latitude and longitude map. All right, see what's going on here in this image. Lat has everything to do with the amount of energy that is being received by the sun, and see the latitude here is 0 degrees. That's where the bulge is on the Earth, the bulge, and yeah, that's receiving most of the energy from the sun, so this is going to be very hot. And see how this is directed back? It's directed back away from the sun. Well, these guys aren't going to be receiving near as much energy, flat, and it's going to be much colder up here. So latitude has a big, big impact on climate. The other thing that has an impact on climate is proximity to a large body of water. And we're talking like the ocean, like that big. And so if you're here on the coast, you're going to be impacted. Now, there is a cold water current that goes down through the west side of North America, and that cools everything off through here. Where on the Atlantic side, we have a warm ocean current that comes up through here, and that impacts us tremendously because, I mean, from just experience that Florida is a very hot place. Well, you have a current that just goes right through there and comes up and kind of branches off, gets colder and comes down right through here next to Europe. So Europe is impacted by a cold water current, where North America on the East Coast is impacted by a warm current, and that impacts weather and climate tremendously on us. So lat, and then proximity to water, and then elevation. Elevation and weather. Elevation and weather. Yeah, that's going to have an impact. Because of this picture right here, hopefully it's big enough. It looks like it's a pretty good picture. I don't know if I can make it big enough though. The higher you go, the colder it gets. So as you're going up, it gets colder, and you have condensation going on, and so you have snow-capped mountains. You have snow-capped mountains right there due to elevation. And the last thing is, mountain ranges, and those things create something called a rain shadow. And I can pull up a rain shadow right here. I hope I get a good picture. Again, I only have 10 minutes. I can't really search this and find really good pictures. Maybe this will do. All right. This kind of has three things going on in it. You have the sea, the ocean, which I was talking about, the ocean. You have elevation, and you have your proximity to a large body of water. You have elevation going on here, and you have the barrier, the mountain range. So when this water is coming off the ocean and it's making its way up, it's going up, and it's getting colder, so it starts to condense and drop all its precipitation on this side. By the time it gets over the other side, it's tired. It's released everything, and this side doesn't get near as much precipitation. So you have evolution. You have all kinds of things going on here. You have animals that are adapted to a cool, I guess, moist environment, and animals that have adapted to very dry, harsh environments, very hot, warm environments on this side. So rain shadows have a big impact upon not just climate, but life, evolutionary factors going on there. Earth's surface is much more efficiently heated by the sun than its atmosphere. Now, when they talk about surface, just don't think about like the ground. Think about the water. Again, water, the heat engine of the planet is the ocean, especially the equator region, the lattice flat thing. That is where you have, you really have the energy being absorbed. Gas, the gases in the air, they don't hold heat very well. They move around because they're excited, and something's causing them to move, and then they just, once the source of energy is gone, they just cool down right quick. Think of this. Think if inside your house and you have the heat on and it's wintertime, and then the electricity goes out. When the electricity goes out, it starts getting cold pretty quick because the air molecules are moving pretty quick when the energy source is there, the electricity. But when the electricity goes out, and then you don't feel the heat anymore because they're not bouncing into you, and you get cold. All right, so atmosphere doesn't hold the heat very well, but the surface, it's not what's coming from up there, it's what's coming from down here that holds the heat and drives everything. All right, winds are created by uneven heat distribution. That's the thermals. That's the thermals that I had pulled up a few minutes ago. Now they're gone, but the thermals. All right, convection is in the atmosphere. Well, I'm sorry. I'm out of time. I only got 20 seconds left. I definitely want to say goodbye to you guys. I'll see you soon, and this is my last video for the day. So write some of this information down as directed by the sub, and I'll see you soon. Peace out.